Yeah, hi. So, good evening, everyone, and we will start this webinar or the live class, whatever we call it, right now. Yeah, so let me share my screen without wasting time, and let's get into the discussions. So, how many of you are excited to learn about all the crashing of the flight into building, how we can prevent? Is it something which is preventable? So, how many of you think that something of that nature is preventable in terms of building collapse? We know accidents are not really possible to uh, avoid, but then how can we ensure a complete building collapsing if something of that sort happens? Tell yes if you think it can be controlled, say no if it cannot be controlled. Type in your answers. What do you think about that? We can build walls around the building. No, that's not something which you cannot, something which you can do. Okay, so let's see. Yeah. So, how to control disproportionate collapse? That's what we are going to focus today. Yeah. And we will also define a few things before we move ahead. So tell me, what do you mean by an accident? Define an accident. Who can do that? Just type in what do you mean by an accident? Define it. Can somebody do it? Very quick. Define an accident. Any answer? No answers? Hazardous loss to mankind. Okay. Anything that occurs suddenly? No. Better. Earthquake. Okay. It's an example of a accident. Unpredictable events? Yes. Okay. So let's very quickly define what it is. What is an accident? Yeah. It is an unfortunate incident. Yep. That happens unexpectedly and unintentionally, typically result in damage or injury. Yeah. So that is what an accident is. Now, anybody thought this would happen? Say yes if you had thought something of this kind can happen. Say no if you hadn't even thought about such a uh, unpredictable thing happening. Yeah, so who thought that a flight is going to come and hit on a building and crash there? Perhaps not many. Yeah, while a flight coming and hitting over there is a possible accident scenario, a complete collapse of a building, controlling that is a possible scenario. Okay, so let's see one by one. So this is the image of that flight that crashed into the hostel building in Ahmedabad. So before we move forward, let's spare a few moments, at least a moment, for the departed soul who are affected by the accident. Yeah. So let us keep them in our prayers. Let's hope that such an accident never occur again and people don't lose lives. So a moment. Okay. So accidents are unfortunate. It is unexpected. And it is, of course, unintentional in many cases. Now, there can be intentional accidents where people make that purposely, like a terrorist attack. Otherwise, everything is unfortunate, unexpected, and of course, unintentional. Now, the psychological part of that, yeah, many of us or most of us, we think that accident happens only to others. So, how many of you here think that accident happens only to others? We know that it happens to anybody, but then still our belief, our inner mind tells us that it happens only to others. So how many of you think that accident happens only to others? Say yes if you think, or at least at some point in time if you had thought like that. Say yes if you had thought that accident happens only to others, at least at some point in time in your life. When we see an accident, even at that point in time, we think like, okay, somebody met with an accident. You never feel like, okay, I can be there tomorrow. Correct? Okay, so nobody's saying yes. Okay, then tell me, uh, how many of you have health insurance and life insurance covered? Say yes if you have life insurance as well as a health insurance to cover your health and life. Amit says yes. Okay, great. So many are having yes. Varsha says no. Okay. Why no? Yeah, so you have to have a cover. That is one of the first investment that you should be doing. Okay, health, especially when you are a youngster, maybe health is the first thing that you need to secure in the current times. So we generally don't plan. That's why we saw a few no there, no health insurance, no life insurance. That's not great to have. Yeah, so please plan. Generally, many people don't plan at the right time. Okay, so we need to plan. Now, our main agenda is going to be why we plan, how we plan, and when we plan. This is with respect to controlling disproportionate collapse. Okay, so our main agenda is that why, how, and when. When should we do this? So the main agenda, a quick glimpse of the Air India accident. We will run through what happened. A quick history of progressive collapse. What is meant by risk analysis? We are going to touch up that. How mitigate disproportionate collapse structurally, and a learning offer for attendees. Yeah, that's going to be a offer, and then we'll have a question and answer session. So this is our agenda today, and a bit about me before we get into. Hope some of you know me. So tell me how many of you have attended my previous webinar. Say yes if you have attended, no if you have not attended. If you are my student, say student. So there are a few yes and a few no and a few student. Okay, great. So I'm a structural consultant, and of late I've been helping engineers learn structures in a seamless manner. And I have about 25 years of experience, and I have been uh, teaching and consulting for the last 10 years independently, 25 years all put together. And most of my work life was with these two consultancies in Bangalore, Sterling and Atkins. And I've been doing projects based in India, UK, and the Middle East. If you are keen to connect me, please search for Premjit Vasudevan in LinkedIn, and you are welcome to connect me. I am an open networker, so I'll be accepting your connection request provided you have your profile. Yeah, you should have your name, and you should have some information about you, what you do, and things like that. And my vision has been to improve the profession of structural and civil engineering and enabling interested engineers to pursue learning. And lastly, I wanted to say that in this class, we are going to do a few things in ETABS, quick things, but simple things, and important things which will make your work life different. So I'm showing the slide again where the crash occurred. You can see the tail part of the flight. Now here you can see the inside of that hostel building, I suppose, where the wall is very badly damaged. Here you can see the hostel building. Here a lot of fire and other things have also occurred. I get to feel that way. Here you can see there is quite a lot of fire. Here also you can see the crash site, a lot of fire. You can see again fire, the tail end where it crashed inside the building. The slabs of the roof also got damaged. Here you can see the slab part completely having a lot of problems. The columns all chipped off. But one important thing I wanted to say is that compared to the nature of the accident, the building damage is not so high. Yeah, so this building has not collapsed disproportionately. Of course, the fire um, damaged the building a lot. The fire was one of the main reasons that people lost their lives as well, the blast and the fire. The building has survived. It has not collapsed disproportionately. Now, why it didn't, we'll see that, and how we can ensure our buildings don't collapse. Yeah, there was a bit of luck plus a lot of design that might have happened in the building that resulted in a lesser structural damage. There are structural damage, but then compared to the nature of the or the magnitude of the accident, the damage, there is no disproportionate collapse as such for the building. Now, fire, we could have prevented that. Not in this case, because it's a huge fire and it is triggered by the fuel. So it's impossible that we can control that. Yeah, but still, with respect to structures, how you can cover or how you can prevent fire, who can tell me how can you reduce the fire damage structurally? There are many other ways that you can do it, but structurally, what is the way that you can reduce the damage? Tell me. Type in your answer. How can we reduce the fire damage to a structure? Who can tell me? Fire structurally, increasing clear cover, yes. Increasing the member size, and after that it's only fire protection and hydrants or whatever. Yeah, so mechanical means or other means. Okay, structurally all you could do is um, using more cover for RCC building I'm talking about, and using insulation, and using uh, more member sizes. So that's the only thing that we can do. Yeah, but then this magnitude of this fire and the heat that it generated is not something which we could ever control. It's huge. Okay, so let's not think about structurally mitigating that. You know that IS 456 has certain stipulations on fire rating. If it has to meet 4 hours of fire, what should be the cover, what should be the member size? It's available in IS 456, the member size and the cover required. If you are new to that, if you are not aware of it, please feel free to contact me. I can guide you with the code clauses. Okay, so this is a summary of the structural and interior damage I could gather from various sources online. Yeah, so I'm relying on the news and various channels for summarizing this. So rooftop heavily impacted. The tail section and rear wheels crashed through the hostel's roof. You can see that in the image. Aircraft debris embedded in walls. That also we saw in one of the image. There were widespread fire damage, and there were structural damages as well, but then there was no disproportionate collapse. Okay. Now, summary is that it was an unfortunate accident. However, building performance was not very bad. There was no disproportionate collapse. Main structural members has not collapsed. There is no total collapse, but crash impact is huge, so walls has collapsed and fire did a lot of damage. Now, what if the flight had knocked off these columns? Then things would have been different. Yeah, here you can see that the flight probably crashed onto the roof, and through the roof, since the roof and the wall joint broke, it uh, got stuck inside or somewhere here. But what if it had crashed onto the columns? Yeah, here you can see columns are damaged, but then that may be the wings or some other portion bracing over this. Yeah, but what if the hit itself was on the columns? Probably the columns would have failed. So let's see that. Let's also try to simulate that in ETABS and see towards the end what happens. So please stay tuned. I'm going to show you few things. Yeah, few methods on how you can look at the disproportionate collapse. You will have to take it forward though. Before that, let's understand a little bit of history on disproportionate collapse control. Yeah. Who can tell me the history? Which building collapsed first? Which triggered learning or research on disproportionate collapse control? If there is any MTech student here who is wanting to do a thesis, maybe this can be a good topic. How to control disproportionate collapse or how to control progressive collapse. Okay, so this building, Ronan Point, yeah, you can see in the images. It's a building in the UK. You can see the collapse. I will tell you the way that it crashed and the history behind that in the next slides. Okay, so what is that? On 16th May 1968, long time back. Yeah, how many years? Almost 40 years. Yeah, a gas leak in the flat 90 on the 18th floor exploded. What happened? Blowing out a load bearing external wall panel. It was a precast structure, the internal walls and all that. This triggered a progressive collapse. The southeastern corner of the 22 floor building came down. Yeah, that's what you are seeing in this. Probably the cooking explosion happened in the upper level and it triggered a progressive collapse. Yeah, so you can see here in the two images. Around four people lost their lives and a lot of people got injured. Yeah, not a very major loss of life, but then there was a lot of loss of that particular building. So this disaster became a global turning point in structural engineering. That is the legacy of this particular failure. Yeah, and it triggered a lot of research and studies, and something known as robustness became a engineering design principle, especially in the West. We are yet not really adopting it. In some of the codes, it's incorporated in the steel design codes and all that. It's incorporated in a indirect way. It may not be directly telling you that this is the reason that you need to follow this, but it's all there. Okay. Even in some of the load related codes, it's indirectly mentioned, but not directly. Yeah. A concept known as robustness. So this building failure has a legacy. Now, what is disproportionate collapse? Collapse to an extent more than the cause of collapse. That is, say, a minor thing occurred. We never expected or expect that the entire building will collapse. Yeah. Say a small wall, a very thin wall, 100 millimeter wall inside a kitchen, just falling over, the entire 17 floors coming down. That is not proportionate to the reason of that collapse. Yeah. A minor incident, a local member failure resulted in the entire building failing, which is not fair. Yeah. Which is not right. If it's engineered, it should not occur that way. Okay, so that is what disproportionate means. Yeah, that can result in disproportionate number of people losing lives or getting injured, or even um, uh, people wasting, or the client or the owner wasting or losing money. Maybe that it's an important building which becomes non-functional. World Trade Center is an example. Yeah, US. It was a disproportionate collapse, but then that was a terrorist attack, a planned attack, again, a flight crashing onto the building. And it was a steel building mostly. And fire again became the reason for the entire building to collapse. Yeah. So that is something which is unfortunate as well. Okay. So a partition wall triggering an entire collapse. It's again not proportionate to the reason. Yeah. So Ronan Point was not a great failure, as in there is no reason that it should fall so much. And a progressive or non-progressive, a disproportionate collapse can be progressive or non-progressive. Now, what do you mean by progressive and non-progressive? See, if you look at this, it progressed, as in the wall crashed onto this first slab, that slab crashed and fell into the next one, that fell into the next one, and so on. So that is progressive, one after the other. Yeah, but a disproportionate collapse need not be always progressive. Say one floor building or only one floor collapsed. Yeah, but then a very large area of the floor collapsed. That is also disproportionate. Okay. So it can be vertical or horizontal. It need not be like vertically coming down. A big floor horizontally failing is also progressive. Can be, I mean, can be disproportionate. Okay. So keep that all in mind. Our idea is to reduce the amount of failure for a small reason. Yeah, if there is a big reason like a flight crashing and getting a blast, I mean the fuel tank blasting, then we cannot do much. Now, why should we attend to this issue? As I already told you, results in a larger collapse, loss of life, loss of money, and loss of time. Yeah, so we need to avoid this. That's our idea. The whole idea is that. Okay. Uh, is it relevant to attend this in India? Definitely yes. Why? Because all this has occurred in India also. Yeah, many times we will not think very much into that. That's a different thing. But then there has been a lot of instances in India as well. Now, will it be economic to attend to that? Will it be economic if we do a disproportionate collapse control? Many times, yes. Let's discover that by further investigating. That's our idea today. All right. Now, what do you mean by robustness? These all things together, put together, makes a building robust. Okay, so now we have to do a risk analysis in order to make a building robust. Let's see how we can do a risk analysis in some time. Okay, it's not a big thing. Yeah, it's only a logical process, nothing more. Then a good detailing is a step that ensures robustness. Many times, especially engineers, believes detailing is a low end work and they don't attend to that. It's a detailer's work. As an engineer, I'm not going to detail. I'm going to leave that to a person, a junior. Let him sort that out. Let the site sort that out. Wrong. Yeah. Why? Because detailing is what conveys your design into site. They don't know ETABS. They don't know anything else. Your communication to site is detailing. You're not going to call them every day. Yeah. So your detail, the level of your detail, the correctness, accuracy of your detail is going to convey or ensure that your design is going to be built. Okay. So it needs to be really, really right. You need to spend as much time that you're spending for your analysis and design on detailing as well, or you need to have a robust mechanism to capture errors and ensure that everything is right. Yeah. So your notes, your construction sequence, your neighborhood of your site, level differences, if any, existing buildings around your site, everything are important. Yeah. All these are part of detailing. Connections, column to beam joints. If it's steel, even more important, connections. Yeah, connection details. You might have designed your members all fine, but if your joints are not detailed out correctly, gone. Yeah, that will be the weakest point and you will have a collapse. Yeah, you will have disproportionate collapse. Your building should have ductility so that if ever something happens, the failure or the collapse is gradual so that people are able to evacuate. Yeah. So there is a code of practice itself for ductility 13920. Yeah. And these are things that we cover in our day-to-day trainings. Yeah. In mentoring and everywhere. Continuity and tying. What do you mean by that? All your members, all your columns are to be tied. Yeah. Now, what do you mean by that? Tying. Say if you have untied column, the chances of an alternate load path is very, very rare. Say you have something like this, a column here, a column here, a column here, column here. I'm just randomly putting some columns, okay? And say you decided that, okay, this is not in line. I'm not tying this. And here also I'm not tying. Here I'm giving a beam. This is my scheme. So this column is not tied. This column is slightly off the beam, okay? It's better you have a continuous tie so that you get alternate load path. Yeah. Everything should be properly tied so that the sway is less. Yeah. There is an alternate load path. There is a possibility of an alternate load path, things like that. So tying columns are very important to achieve robustness. It also gives continuity for the load path. There should be no weak links. Then wherever needed, you need to have more security and safety. Yeah, sometimes you need safety aspects, as in, say, overload could be. During the construction, there should be no storage. Say you are doing a flat slab and you want to avoid people storing sand or cement bags or something near the column or near the or on the flat slab. Yeah, because it can be dangerous. It can create um, shear failure, sudden failure. Yeah, so there can be many things like that. So if you are a structural engineer, you should also ensure that these kind of things do not happen on critical places during construction, even after construction. But after construction, it's not in our hands. But then, as per code, you are required to write down the load that you have considered and what can be done, what cannot be done, all this. Yeah, but then sometimes that's not in your hands. But definitely during construction, you need to have your instructions going. Yeah, supervision, there should be good amount of supervision. It's not just structural responsibility, it's a shared responsibility to have supervision. Yeah, why? Because only then you can ensure your detailing is executed, then only you can ensure that it's secure and safe. Okay, so supervision is also very much important. So improve all this, then you can achieve robustness. Now, most important thing in my opinion is redundancy. Yeah, what do you mean by redundancy? Type in, who knows? What do you mean by redundancy? A simple word for redundancy. Type in, especially those who are doing your MTech. You said there are a lot of students here. So tell me, what do you mean by redundancy? Any answers? Josie says alternate load path. Krishna says additional load path. Yes, you need to have multiple load paths. Yeah. So let's see how we can establish all this as a structural engineer before your designs are built. How do you ensure uh, we have more redundancy or more alternate load path? So the first step that you need to do in order to establish your role as a structural engineer to control disproportionate collapses, doing a risk analysis. Okay, so it's again not just your responsibility, it's a shared responsibility of all the stakeholders. Let it be client, let it be architects, let it be other consultants like MEP, let it be anybody involved in that project. He is responsible or should be doing a risk analysis. Yeah, as a structural engineer, you can initiate this discussion and then make the client responsible and aware about such a requirement. Okay, many times clients would be okay to do it. They are not aware that such a thing is going to help in the long life of the building. Yeah, so you need to identify all the risks. It's not just a structural responsibility, anybody can do it, and primarily client should be more interested in this. Yeah, or if you are a builder, if you are a contractor, you should be more interested in this, because it's you who are going to get affected first before a consultant. Okay, anyway, as a structural engineer, since you are informed about that, since you will be able to make an understanding or a guess about a problem, you can initiate that discussion. Okay, so first thing is identifying the risks. Yeah, then you need to identify, say the risk can be anything. It could be, in this case, since the building is near a flight path, a flight crash should be a risk analysis, should be part of, I mean, should have been identified in a risk analysis. Okay, if there is something else like a river which is dangerously overflowing every time, then flood could be a risk that you should identify. Fire, if there is a gas bank in the building, definitely fire is a risk that you need to identify, like that. Yeah, if there is something else that can fall on the building, yeah, if there is an overhead crane moving and then there is a chance of something being dropped, that is a risk. Terrorist attack is a risk that you can identify, depends on the kind of the building. Yeah, so identifying that risk is the step number one. Second is identify who and how to mitigate that risk. Yeah, could be that if it's a fire, which is that you have identified as a risk, you need to decide, is it going to be mitigated by structural means or by MEP means? Are you going to have more security who are going to look at ensuring that fire is not going to happen by ensuring that people are going to use say gas bag and area more carefully? Yeah, so that way you can mitigate. Every time you cannot or you need not do it structurally. It can be another means. It could be that you are giving more security. It could be that you are giving more fire hydrants. It could be that you are automating something. Yeah, whatever it is, it could be that you are insulating, whatever. Okay, and if that is not being done, then structural is an option. Yeah, why structural may be the last option many times? Because that might be a little costlier, and maybe functionally it might affect, because you may need more member size and things like that. Okay, but if there are things that are purely structural and only possible by structural, or if things are not attended by other means, then structural attention is required. Yeah, so that way you need to identify risks, fix the responsibility, see who is going to do, how is it going to do, and if structurally need to be done, we have to do that. Okay, so um finally we'll do an ETABS check, but right now let's discuss this in a little uh, detail. Yeah, so or else let's do that right now and then get into more discussions. Okay, so I'm going to take an ETABS model, a very small model, okay? But then I'm going to tell you the principles. Let me also establish one more point. Are there any architects or building planners over here who are into planning? Who are into planning of your buildings? Architects? Anybody? Say yes if you are. I want to tell you something. Rohan. Okay. Then who is that? Teja. No. Who is that? Narayanan. Okay. Anybody else? Only two. Okay. So let me tell you one thing. Say I have Harshavardhan says yes. So there are a few planning engineers or architects. Okay. So let me make a plan. Yeah. My writing pen is not working. So I hope this you can treat it as a square. Okay. Now say that you have a building, say 10-floor building. All right. And this is only 6 meters. And I have a column here, square or circular, whatever. Yeah. Like this. And 6 meter is not something which is impossible. You can do. Yeah. How many of you think that 6 meters spanning beams and four columns around that room is adequate? How many of you feel that it is adequate? Say yes if you think that it is adequate. Say no if you think that it's not adequate. Many says yes. Okay. Okay. 90% of the people are saying yes. I think 100% who answered all are saying yes. Okay. 6 meters. Only 6 meters. Okay. Now, the slab thickness is slightly going to be high, so maybe we'll have a secondary beam. Yeah, why? At least one secondary beam, so that this becomes 3 meter, 3 meter. Yeah, so the slab thickness can be 120 or something like that, or yeah, 100, 110, 120, 125, whatever, 4 inch, 5 inch, whatever. Yeah, the thickness of the slab can be managed. Yeah, one beam either in this direction or in this direction we would give. Okay, so this is a simple thing. Say it's a 5 floor, 10 floor, whatever. Yeah, this is something which is possible. But think about a scenario. Say the same kind of flight came and hit on this particular column. Or say, whatever, a truck came and hit. What happens? You lose one column, correct? One column is gone. Now comes all the problems. Yeah. In a normal case, no problems. An accident. Now you need to have a 6 meter cantilever. Yeah. 6 meter cantilever. Will it stand? Will it stand? Unlikely. Yeah. It is unlikely that it will stand. So more than 50% of this building is going to come down if you do the scheme. Yep. Now, like that, you have four key members. Yeah, four. It could happen to this. 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 So you have four key elements. Yeah. Any of that failing, more than 50% of your building is going to collapse progressively. 10 floors are going to come down. Yes or no? Most likely. Yeah. Otherwise, there should be some magic happening. If there is an accident, yes, it's going to come down. Now think about this one beam failing. If this beam fails, this beam is also going to fail. If that fails, this slab is going to fail because it's 6 meter by 6 meter. All right. So this beam is also a key member. This beam is also a key member. Probably this beam, not as much. Okay. So it's a very critical scheme. Now, if you do this, and if it's an important building, and if you need to control disproportionate collapse, it won't be possible. Yeah. So as a planner, you need to know, or you need to be sensible enough and sensitive enough to provide a column here. Maybe even here. Maybe even here. Maybe even a beam here. Okay. Now, think about removing one member at a time. See, multiple members failing at the same time. We cannot do much. That's not in our hands. We can't do anything about that. Yeah, that's not at all in our hands. If all the columns fail, don't ask me that. Yeah, that's something which we cannot manage. But if now one at a time, if you think that something happens accidentally, see, accident, we cannot expect every member to fail in an accident. If that occurs, that's something fate. We cannot do much. Okay. So here, now think about one column going off. Now the advantage is, what is the advantage? This can act as a 3-meter cantilever because you have a column here. Earlier it was 6 meter and without a back anchorage. Yeah, if you had a beam 6 meter, this need to bend like this. Probably this rebar cannot, it will be a huge moment. Here you have a back anchorage, one span is there, and then only 3 meter. Okay, so that chances of it standing is more. And why it will stand? See, please note, I will show you that in ETABS. Please note that this beam or this structure would be designed for earthquake, wind, everything properly. Okay. So when you have three columns like this, okay, you would have designed it for earthquake. So you would have had something like this. You have a second layer here. You have a second layer here. You have a second layer here. Okay. Now, when this is your detail, and when this column is failing, this needs to stand only for dead load, live load. Because during accident, you don't think about earthquake. If that accident is earthquake, that's a different thing. But if that's a plane coming and hitting your column and this column completely failing, now don't think about earthquake at the same time. Yeah. So now you have this steel, say 216 and say 220. Because of earthquake, you had that steel. Now, without earthquake and without factor of safety, only for dead load, live load, whatever I mean, this is not needed now because this column is not there. So it's a cantilever. Yeah. It's going to behave like a cantilever. Okay. So this cantilever moment, this steel might be good enough for dead load, live load because you have designed this for dead load plus earthquake multiplied by 1.5 combination. Yeah. Right now, what we are looking at is dead load plus live load, and this live load would be less also. Full live load would not be there. Yeah. So it can cantilever 3 meters. Maybe it will deflect more, no problem. Because our idea is not worrying about deflection. Our idea, our worry is only about people losing life. Yeah. Repairing not possible to repair, all that is fine. At least people should be able to move out. Yeah. So it should be possible with a 3 meter cantilever like this. Yeah. So keep that in mind if you are a planner. Yeah. Think why structural engineers needs It's just like you say that shape, yeah, form, function is all very important for you. Yeah, robustness is something which is like your insurance. Yeah, you will feel like, okay, I don't need it, but on that day, on that one day, maybe in the life of that building, you would feel okay. On that day, if I had agreed for one column, maybe that building would not have fallen down. Yeah, so it's like an insurance for you. Yeah, so you need to look into it. So let me quickly show you this in ETABS. So your logic should let you know to think in this manner. Okay, your logic should let you think in this manner. So if a beam is removed, how much of slab? See, if this beam is gone, nothing would happen if you have detailed this slab properly. Yeah, because for an unfactored combination, it can act as a one-way slab. Yeah, so even if this beam fails, nothing would happen. But if you had no beams, if it was 6 meter by 6 meter slab, if one beam fails, it cannot span as a one-way 6 meter. It is unlikely it would stand. Okay, so that's why tying more number of members, yeah, all these are going to be helpful. Long spans are going to be dangerous. Okay, so right now, let me show you this design. I have done a proper design of this earthquake, everything. I cannot show you modeling everything right now because our time is limited. So what I'm going to show you is it's all loaded, it's all designed. I'm going to display the design of, say, maybe the seventh floor here. Yeah, I'm going to show you the seventh floor design. Column design, I'm not taking right now. I'm showing you one, the beam. Okay, so I'm going to display the design steel of the seventh floor of this particular building. So design, concrete design, display design info. I have kept it ready. Total reinforcement. I think I have not designed, I have only analyzed. So let me design this. So select object type, beams, design, concrete frame design, overrides. I will do an ordinary design right now. Those who don't know ETABS, that's okay. Only the result matters. Okay. From the result, you are going to infer and learn something very important. So combination. All the 26 combinations are there. Static analysis I'm doing. Design. Concrete frame design. Start design check. Okay. So you can see the steel uh, in this particular beam. Okay, there is no third column. I have not given the third column here in this case, only 4 columns. Now, let me take one more ETABS model. It's opening up. Give me a second. Let it open up. So you can see here 925 steel at the top. Here also 926. And at the bottom, you have 509 steel. Yeah. Since I've shared it over Zoom, it's taking a little time to open up. Let's wait. I should have opened and kept it. Okay, anyway, it's open now. It's a little slow over the network. Give me a minute. This is the second model that I'm opening, wherein I have removed one of the column, just like I told you. Yes, I'm going to show you the design after removing that. Give me 1 minute. So how many of you here are completely new to design? Say yes if you're completely new, first time seeing ETABS and first time doing something of this sort. Say yes if you are a first timer. Let me know how many are beginners when it comes to any of the design. Sachin says, Gauri says yes. Akshit Gaur says flat slab. Okay. Maybe something else. Shivalal says yes. Okay. So let me open the second model. Okay. So here you can see in the seventh floor, what I have done here is I have removed the columns. Yeah. This, what you are seeing is a grid. So let me um, show you that. Yeah. I have removed that particular column. So in this level, it's kind of floating. And here it should be a cantilever. Okay. So let me see if I have designed this. If not, I will again design this also. So design, concrete frame design, display design info, design output, and apply. So here, please note that I have designed this only for dead load, live load. Define load combinations. I have created one combination here, which has dead load and live load alone. No earthquake, nothing. Even live load I can slightly reduce, because if I have taken 3 kilonewton or 4 kilonewton per meter square as the live load, generally that much live load will not come. Code is generally conservative. Yeah, so I can actually reduce a bit of live load, but I'm not doing it. I have done it for a full live load. So let me come to the seventh floor and show you this steel required. Okay, now see this. Only for dead load, live load, and unfactored, you need 2271 steel here if this column goes off. Very huge. What was our steel earlier? We had only 926. Now we need more than double that. I mean, this we need to do it before building, okay? Before construction, we have to design this and do it. We cannot do anything after the collapse occurs or during the collapse occurring. Yeah, so this you need to attend in design, which means you have to increase this 926 to what? 2271, which is a huge increase. It will be uneconomic to do that. Yeah, sometimes it may not have capacity also to take that. Now, if you give 2271 steel, and if it's a 230 by 600 beam or something, you might have to increase the thickness also, I mean depth also. And in 2271, if I give 490, that is 25 diameter bar, which area is 490, I need around 5 numbers. Yeah, so there will be a lot of congestion here. And when you have a congestion, how can you anchor 5 number or 6 numbers of bar, 25 diameter bar into this column? Yeah, your turning radius, all that, it's going to be really congested. You have column rebars. It's not something which you can really practically do that. Your cost also will be very high. And you have to do it on all the beams, because maybe that this column is going to fail, maybe that this column is going to fail. So this is not looking practical. It's not going to be economic. Okay, and this is something impossible. Maybe this column is going to fail. Yeah, or you will have to make the column size also large, steel also large. So it's not going to be economic to do that. That's why scheming is going to be the uh, uh, rescuer. Yeah, so if you have a good scheme, then all of this is going to be easily possible. Okay, I am going to show you that also, why the scheme is going to be very, very useful. Yeah. Uh, so before doing that, let me show you one more thing, the upper level. Okay, so here you can see, here also it's a cantilever. Okay, here also it is a cantilever. In the lower level, it is not a cantilever. You can see the steel is very less because you have column on either side. And you are designing it for only dead load, live load. Here it's a pure cantilever, the steel is high. And in the upper level, you were expecting it to have even more. Why? Because there is also a point load here. Yeah, a floating column. But maybe it is slightly less. Why? That's where all your detailing, connection detailing, all that will help in some alternate load path. Probably this is acting like a suspender. Yeah, so you need to ensure that this column has a tensile capacity. In your normal design, you would only look at its compressive capacity. Yeah, even if you look at its bending moment diagram, uh, let's see. I'm not sure. Let's see. See, here it's a pure cantilever. You can see the cantilever moment. Whereas here you can see something else. Yeah. So it becomes very important that you attend this in your analysis and design, and also consider this fact. Maybe that your terrace has some larger beam. Maybe that the load was less in the terrace and you thought like, okay, let me standardize everything only for one beam. Let me not reduce its depth and steel. Let me give the same steel, whatever we have here, and maybe the same depth, whatever we have. Maybe tomorrow there can be a water tank coming over here. Today it's not there. So let me give the same design for whatever you have for here, even here. Which means that this beam has more capacity than actual. So instead of this being a floating column, can act as a suspender from this particular beam, provided you have one more column here and things like that. Yeah, so maybe that this beam can act as a small cantilever and this column can act as a suspender and help in suspending this particular floor. So this may not collapse. Yeah, because we have designed it for earthquake and we are now considering only dead load. We have only dead load, live load, or maybe dead load alone. Live load may not be significant. Yeah, so this will save your building, but then you should have ensured that your steel are through and through without much laps. And if ever there is a lap, you have tension lap in your column rebars and things like that. And this connection, this joint is properly done. Normal detailing, correctly done with correct LD and all that. If you have ensured, this can act as a suspender also. Yeah. So what felt like a floating column for you in the event of an accident is acting as a suspender. We never know. So that kind of redundancies you need to establish during your design. That is what a good engineer should do. Yeah. And if a good engineer, if you do that, clients will value that. And that's how you add value to a project. You need to demonstrate that. You need to tell them, this is what I can give you and this is why I'm charging you more. Otherwise, you will end up charging 2 rupees per square feet or 3 rupees per square feet or whatever is prevailing in the market. Yeah. So everything you should add value. And for these projects which are sensitive to disproportionate collapse, it works that. Yeah. So you need to convince your client and make him aware of such things, practices, and possibilities. Don't think that everybody wants. Our main problem is that we assume too many things that everybody wants. I have heard people saying, hey, architects will always want will always object columns. I have seen many architects who are receptive of these ideas. Same way with clients. Yeah. So your success lies in identifying that kind of architects and clients. Yeah, who are valuing all these, and don't assume everybody are alike. It's not that. Okay. So that's one point I wanted to tell you. Now, let me take the other model as well. So I'm done with this. I'm taking another model now. Give me a second. It's taking a little time. Okay, so how many of you think that this is a good topic you are understanding? Say yes if you are liking this topic. If you don't, be honest, no problem, because our idea is to know what you like and what you don't like, and do sessions on such topics which you are liking. Yeah, so if you don't like, it's okay. I don't mind. Yeah, so if you like it, say yes. If you don't like it, say no. That's okay. Okay, so many yes. Okay, so let me come to the next model. So I think the name of that was this one. Okay, so here what I have done is differently is uh, I have kept that one additional column. So let me take that particular plan. Only thing I have done is I have added one column, not here, in one location. Actually, here also adding is better, but let's do that. I mean, you can do that. You can test that later. So I have added one column here. So let me design it. I think I have designed it. Let's see. If not, I will design it again. So here now you can see that the requirement of this is 761. And this is done with all um earthquake analysis. Everything is done. Yeah. And you are getting this kind of steel here. I think the seismic zone I changed in this. I'm not exactly remembering. Anyway, now this also let me change and take another model where I have 3 columns and a collapse. Give me a second. It's taking again a time. I think this was the model. Let me switch off the grid so that it's clear. Yeah, what I did here is I took off the entire one column here. That is the case that we discussed. I took out one column. Completely I removed. All floors I removed. Yeah, it could be that it's gone in only in one floor like the earlier case. It could be that it goes off in 2 floors. It could be that all the floors went off. So let's take it like this. All the floors went off. And maybe we will consider first floor, not seventh in this case. First floor still, let us see. Yeah. Now here also, let me take the first floor. Okay. Let me display design, concrete frame design, display design info, and total long steel. Okay, so see this. What you can see here is a beauty. Yeah, structurally. Why? Because dead load, live load is giving you a steel of 151, 212 will suffice for this cantilever, 3-meter cantilever. Okay. And what we have is much higher. 724 you have, because you have done this for zone 3 seismic design, which has resulted in 724 steel. Even if this column is gone, it can cantilever across. That's what you are seeing here. So without 1 rupee increase in your cost, your building is going to stand. It's not going to disproportionately collapse, even if this column completely goes off. Yeah, if that column falls and injures people, all that will be there. I'm not saying that everything will be perfect, but then a complete collapse of your building is not likely to occur. Okay, sometimes you may have to slightly increase. It's a small cantilever with respect to um, uh, the earthquake design. That's why its steel is so less. Okay, but then uh, sometimes minor increase you might have to do. Sometimes minor uh, extension of rebars you might have to do. Okay, that kind of scenarios might occur, but it's not going to be a huge cost increment. Okay, say for example, let's take another example. I'm not going to do it in ETABS right now because it takes time. Say this column fails. Okay, this column is going to fail. Now, before doing that, let's sketch the rebar detail of this particular beam. Let me clear the canvas. You have two spans. Okay, your detail is likely to be like this. 212 is going to be through. Okay, now I'm not writing the reinforcement and all that. You can infer from this. Say you can convert 761 into equivalent steel. Yeah, 212 plus whatever, 216 plus whatever, 216 plus 216, whatever. You can convert that. I'm not doing it. I'm just telling you the principle. So this is your detail, two layers. Okay. Now the point is this column going off, the central one. It's gone. Say accident happens. Now the point is, how will be the bending moment in your real design? It would be something like this. Yeah, those who are new to bending moments and all that, or who have forgotten it, no worries. You can polish your skills and learn it if you are keen. But anyways, this is going to be the approximate. These values might be different or same depending upon various parameters. And after that collapse, what would be, say, if this is not going to be there, this beam is, this column is not going to be there, it will be something like this. Okay. So whatever was a support here, we had top steel more here. You are now required to have this steel more. Why? Because this beam is not existing. I mean, this column is not existing. Yeah. So during your analysis, before you freezing your design, you should check this. Say this is a key member you are identifying. So when you are removing this particular column, in your analysis, during your analysis time, yeah, before freezing your drawings, when you are checking this, you would get this moment here. You would get a little more moment here, maybe less. Why? Because here this check is done only for dead load, live load. This is for everything, dead load plus live load plus earthquake, 26 combinations we have. Yeah, wind, everything is covered. So this steel is likely to be more, whereas this steel is likely to be not so much. Even though this column goes and the bending moment becomes like this, the total steel might be still less. Yeah, but you might end up having a requirement that maybe that this is you detail it like 212 and 216. Okay, the best method is first layer larger diameter, but say you have detailed it like this, maybe you have to do one tweak, that is swapping the layers. Here you may have to give 216 and second layer 212. Swap first layer and second layer, you swap, so that when this happens, when the collapse occurs, here this moment that 216 can take care. You need to check that. If that is not adequate, then you have to extend this. So this adjustment, and 99% of the cases, in this case, you are seeing it yourself. Without doing anything, your structure will stand as a cantilever. I mean, now we are talking about this beam going. Yeah, even if you remove this column and check, it would stand. Yeah, without any increase in steel, because you have considerable steel in that column. But in that beam, in certain cases, you may have to slightly do this tweak. Maybe that you have to extend a rebar, maybe that you have to swap your layers. So even if that you have to do, the cost associated with that might be very, very less. You might spend a little more, but not so much. And that small additional spending is justifiable because you are going to save your building from a very disastrous collapse on a accidental day. Yeah, so it makes sense to do it. Yes or no? Say yes if you feel that it's important, and a very minor cost increase is okay for that, achieving a lot of robustness. Say yes if you believe so. Say no if you believe it's not needed. Okay, so many are feeling yes, that's a great news. Yeah, because engineering should improve, and this is the way that we can improve engineering. All right. Okay, so how many of you think that as a site engineer also, if you know this, that's going to help you to take decisions? Maybe that you saw this detail, 212 first layer, yeah, 216 second layer. It's cut bars. At site, you have a lot of waste. I mean, it's okay. You have, you can give 216 first layer. It doesn't, it will not be a cost increase because otherwise you are going to throw that, or it's going to be a scrap. So if you know this, you can simply do it yourself. Make 216 first layer, give 212 second layer. You are adding value to that project. Yeah. If you didn't know about this, you will always do whatever is given to you by a structural engineer. You do what is seen in the drawing. But if you know that this is going to make an immense change in an accidental day, you could take that decision yourself. You are empowered to take that decision because you know that first layer 216 is not going to have any other problem. Yeah. So there are many more things that you can add value. Yeah. So you don't need to know full or entire structural design in order to add value to a project, but you need to know a few things at least. Yeah. So rather than doing a supervisory role alone at site, you can take decisions, you can appreciate things, you can add value to things if you are a structural engineer. And site engineering is nothing but application of structures with respect to bar detailing. Yeah, other aspects like finishes supervision, all these are different things. It's not related to structures much. Otherwise, all these are application of structural engineering. Yeah. So a structural engineer should be a site engineer as well, know site engineering also, because then only he knows how can your design be buildable. Yeah. If your designs are not buildable, then that's not useful at site. Yeah. So all that you get to know if you are a good site engineer. Same way a site engineer should be a structural engineer as well. May not be everything, but then it's good to know a few things at least. And for larger projects, there will be a lot of site decisions that you need to take. You cannot always call back a structural engineer and keep asking things. Yeah, so a structural engineer will be a site engineer as well. Uh, Victor is saying a lot of structural engineers will not allow changes to his designs. The point is, they know that probably you don't know much. Yeah, so their egos might be speaking. Yeah, but then if it's for the betterment of the project, I am always open. Yeah, and there are many more engineers who are open to changes. Yeah, so don't take a blanket decision that all structural engineers are non-receptive. Yeah, it's not like that. And if you know things, then you will be able to take more better suggestions you can give others. Yeah, so there is nothing wrong if you correct some mistakes. Okay, so that's about the robustness part. Now coming back to the discussions. ETABS check I showed you. Yeah, and I hope you liked it as well. So our inference is that If we have seismic resistance, then achieving disproportionate collapse resistance is not a difficult thing to do. Yeah. And there are many more margins and things which I have not told you. Yeah. But then uh, basically, if you design properly, you are able to meet disproportionate collapse control. Yeah. So the point is, without your knowledge, so many things are happening behind the scene. Yeah. So if you know it, you will appreciate it like this. If you don't know it, without your knowledge, things are occurring. Alternate load path comes into play. Margin in the load comes into play. Alternate load path, suspender action, all this keeps on occurring without your knowledge. Only that you don't know. Even some structural engineers, I mean, some of you are juniors. I'm not, even I didn't know all these when I was a junior or when I was starting off. Yeah. So nothing wrong about that. But then what I'm trying to say is if you don't know about these, you don't know that, but it's going to occur at site. Yeah. And your building is going to have that alternate load path. And this is one of the reasons. Yeah. There are many more alternate load path cracking and redistribution. And that is why a Mestri is surviving. Yeah. Mestri as in a contractor, a non-engineered building is standing. Okay. So if somebody asks you why a non-engineered building is standing, you can explain it better right now. Yeah. So basically, all you have to do is design your building properly. And if you do that, automatically all redundancies, and especially if your scheme is great, yeah, you are going to have a lot of alternate load path, a lot of robustness. Your building is not going to fail until and unless you make 3, 4 mistakes altogether. Yeah, there should be a design mistake, there should be an overload, there should be a detailing mistake. Many things should occur, or a gross blunder. Okay, a lot of ignorance should occur for a building to fall down. Otherwise, if you have done a proper design, your building is not going to come down. Now, this can be used as a confidence, not for overconfidence, because if you do everything proper, then it's fine. Okay, so if you learn structures, if you are a site engineer, site project manager, architect, or a civil engineer, yeah, then you get the confidence to build. Yeah, you know all this occurs. You can take decisions, all that. Even if you are a detailer, how many of you are here detailers or beam professionals? Say yes if you are a beam professional or a detailer. Anybody? Kishan is asking if I can share number. Yes, I will do that. Give me some time. I'm going to share with you. No, no BIM modelers, no detailers. Any assistant professors, teachers? No. You can all add value to your students if you are knowing all this. Yeah, you can teach better. Your design, you can teach better. Any teachers here? Nobody. That's surprising. No teachers here. No professors. No assistant professors or professors. Gauri. Okay, great. Um, so now, in case if you want to continue learning, I told you I'm going to give you an offer. Yeah. So now my vision has been to improve the profession and enabling interested engineers. So here there is a limited offer I'm going to give you. And this is for a very, very world-class course. Okay. So take this link. I will also share my WhatsApp number as somebody asked here, Krishna. I'm going to share this. If you feel like you learn something and if you can learn more from this, you can take this. There is a huge discount on this and there is also a huge offer on this. I will tell you. Let me first put this into the group. I hope all of you can see that particular link. What you are going to get from that link is a high-end course which teaches you how to design buildings properly. Yeah. And you can see people who have done this program. They are getting jobs. They are doing well. You can see what Danya is saying here. She got into a company called Bureau Happold, yeah, which is one of the largest MNC. and she's doing good. Her probation is over. What I'm giving you here is superstructure analysis and design program, which costs you 10,000 otherwise. I'm slashing it to 7,999 today. And you are going to get 3 years access to that, a certification, a community for discussions and doubt clarification. There will be quiz assignments, a full project explained in it. There will be extra project, and a drawing set is going to be given to you. So it explains you how to analyze and design static analysis, seismic analysis of a mid-rise building. Yeah, everything related to the superstructure, static analysis up to that is covered in that for this particular fee structure. And as an added bonus, I'm going to add in a detailing program for you, which is worth 4,999 free. Yeah, so you are going to get 2 courses for 7,999. So this is my offer for you, those who have attended here in this session today. And if you are a student who has already taken this program, you can contact me. I am sharing my number in case if you don't have my number with you. This is the number. Yeah, you can take a screenshot. I'm also leaving this into the chat. You can contact in this number. You can take the next course or a bundle. We have 3 ways that you can do my program. One is this basic course. Second is a course collection. Yeah, you can take multiple courses at the same time, which will be discounted. 2 or 3 courses, advanced courses, foundation design, similar to that. You get certain discounts on that. And thirdly, you have a mentoring program. Yeah, the mentoring program is a complete program where there will be live sessions like this, where every week you get 2 live sessions like this for 6 months. Yeah, so that is going to be the third way of learning, which is a advanced learning program. So if you want that learning program, the mentoring program, even then you can WhatsApp me. Then we can discuss. If I think, and if you think that it's suitable for you, we can take it forward. Yeah, so if you want an additional course than this, or if you want a collection of courses bundles, or if you want the mentoring program, you can feel free to WhatsApp me. And in case if you want to discuss about this course also, please send me a message. Yeah, so this is the number. I have dropped it in the chat box. If you want, you can also take a screenshot of it, and the link also you can take a screenshot. I have dropped it in the chat box as well. So that's all from me on this. If you have any questions on the content, what we discussed, or on the course or on the program, please feel free to ask me. I'm going to open up for questions and answers. So thank you very much for attending, and I hope it was useful for you, and give me honest feedback, and also the preferred times and time duration, all that if you can discuss in the group. And if you are not in my group, I would suggest you join, because many things I announced there only. Everybody reaching by mail and WhatsApp is not something which I can do on a day-to-day basis. So if you want to be in touch, be in the larger community, please WhatsApp me. I will share you the group link. You can join. Now, let me just stop sharing, and let me give you access to the mic. Give me 1 second. You can pick up the mic and ask me anything that you have to ask. Yeah, the mic is open. Any questions? You can ask about the content or about the program, whatever course or anything if you have. No questions?
Hello.
Chat box, seeing the chat box is a little tough. I can try. Yeah, somebody was asking.
Sir, I have completed your self-paced course completely, but there was a problem. Because I have no software, so your assignment was not submitted to you. Sir, what should I do further? Any knowledge? What course I should join? for you.
Okay, I would strictly recommend you doing the software practice because that is
Software is
very much because that
costly,
is
sir.
because that is very much required. You can WhatsApp me. I will share you how you can get the software and all that. Once you have finished practicing, then you can get into maybe advanced analysis or foundation design. Yeah, but then I would recommend you first practice what you have learned. Seeing is not always going to be learning. Yeah, so finish that and then get into the next course. You can WhatsApp me.
Okay, sir.
Yeah, WhatsApp me
Thank-
and let me see your progression, the assignment submission, and all that. If it's not there, I will try to tell you how you can get the software and things like that. And then we can discuss how to go forward.
Thank you, sir.
Yeah, no problem.
Hello.
Yes.
Sir, can
Who
you
is
hear me,
that?
sir?
Yes, Balasubramaniam,
Sir,
tell me.
Bala. Yeah, yes, sir. Actually, I'm a post-tension design engineer, sir.
Okay.
I have
Yeah,
a
tell
query,
me.
sir, regarding design of beams in seismic zones, sir.
Yeah.
Actually, can we take the tendon capacity, the tendon moment capacity in seismic zones, sir, for designing the beams, or
See,
it should be avoided?
there are many aspects to that. Yeah, there is no one answer. That needs to be a separate session. Yeah, so we can
Okay.
have a separate discussion.
Fine, sir. Okay. Okay.
Yeah.
Thank you, sir.
Generally,
Thank you.
PT is not advised in a higher seismic zone. Yeah.
Okay. Okay, sir. Fine. Fine. Yeah.
Yeah. Let me
Thank
take
you, sir.
one question from the chat. I was associated with Rookie Engineering. Okay, somebody is admitting the fault. Yeah, that's okay. If you have pointed out a mistake and somebody has admitted that, well and good. You have added value to the project. Somebody is asking if there is steel structure. No, we don't provide a steel structure course right now. Balasubramaniam is asking, can I get detailing bundle? Yes, Balasubramaniam, you can get that. Please message me. Harsha is asking, generally when we design a building in software, we get the sufficient reinforcement. But generally when we see some building structural drawings, there are some places in slab. Oh, all that has to be a separate discussion. Or you WhatsApp me, I can share. If I have a video on that, I can share that with you, Harsha. Please, can you message me?
Okay, sir.
Yeah, if I have that, I will look into it. Or maybe we can have another session on all that kind of things. Yeah, based on how many number of people have that requirement. Any other question? Anup is asking bridge design. No, we don't have right now, Anup. Anup is my student, I think. Yeah. Any other question, anybody? If not,
Hello, good evening. Sir, good evening, sir.
yes, Jitendra.
Sir, myself Jitendra, sir. I'm working, sir, oil and gas project.
Yeah.
Sir, I get your software, sir. Sorry, course, advanced structure analysis using superstructure, ETAB, using by UTAB. Sir, your
Okay.
explanation method is very perfect, sir.
Okay, thank you.
Last, sir, मतलब by BTech pass out 2016, and then my RCM is suggest me you got MTech. Sir, I MTech done 2024. Sir, my
Okay.
basic knowledge very, sir, strong for, sir, you.
Okay, thank you. I am happy that the program helped you. Yeah.
Sir, some questions, sir. I open, sir, my conscious structure. Sir, please suggest मतलब और सॉफ्टवेयर चाहिए सर मेरे को स्किल डेवलप करने के लिए सर
ओके
प्लीज सर हेल्प सर।
अब या आप मुझे मैसेज भेजिए, मैं सजेस्ट करता हूँ। मुझे आपसे
मेरा
आपका सी
वर्किंग आवर भी सर मेरा वर्किंग आवर सर 8 to 8 है सर, फिर उसके बावजूद भी सर मैंने मतलब टाइम को मैनेज करके सर आई और मतलब आपके लेसन लिए मैंने पूरे
ओके
सर। डेफिनेटली सर वेरी अंडरस्टैंडिंग सर। Sure.
Okay. अब मैसेज भेजिए, हम बात करेंगे. Yeah.
Yes, sir. Thank you, sir.
Yeah, thank you. Any other question, anybody?
Good evening, sir.
Yes, Shubham.
Actually, sir, I'm following the since so long, and first of all, thank you so very much for this lovely presentation. And this is a very trending topic, so it
Yeah.
felt very great. Just spending around 90 odd minutes on this topic. Sir, actually, I have to tell you something. I have just cleared my state JEE examination, and
Great. Congrats.
I'm about to join in a few months. Basically, I want to be a structural engineer, but somewhere down the line, the opportunities come, and I got selected. But sir, as a learning point of view, I want to learn this basic designing prospects since very beginning because I'm very good in academics, wrote ESE mains twice. So
Okay.
my theoretical knowledge is on point, I guess, from structural analysis, RCC, and steel point of view. But for a knowledge purpose point of view, I haven't studied not a single software yet. But
Okay.
I just want to learn this because I am just done with my academics part and got my career stability as a government job. So now
Okay.
I'm free and just want to enhance my designing skills as well.
Okay. Yeah, you can start with this first program, the offer that I've given you. That's a good point to start.
Okay.
Yeah, you can WhatsApp me as well in case if you have any questions on
Okay.
which
Sir,
to pick. And
one more question I just want to ask. Just last question.
yeah,
Can I
yeah.
do a side work? Can I do a side work with my government job as well?
See, if you
Is this
ask
not
me,
going to?
legal point of view, I think two employments are not allowed. So that you need to think. Yeah. So
Understood.
yeah, that I'm not somebody to comment on that, but
Okay.
then I think
Uh,
it is not
At
really.
what time at what time I'll call you then?
You
I need
message
to.
me. Yeah, you can
Okay,
message
understood.
me. Yeah,
Understood.
and then we can decide a time.
Okay, thank you so much, sir.
Yeah, no problem. Welcome.
Hello.
Yes.
Good evening, sir.
Yes, who is this?
This is Kajal.
Okay, Kajal, tell me.
Yes, I took your basic course. So one question I had, as compared to columns, the pedestal is having just one criteria, which goes by the definition that the height dimension oblique height ratio should be less than 0.3. Right, sir?
Nothing like that. No, I mean, there are too many things in that. Yeah. So, see, there are two kinds of pedestal. Yeah. What we are encountering in a building structure is a monolithic column just thickening up. Yeah. But then you also have a place where you have a short column or a short pedestal. Yeah. So they are two different things. You cannot go with definitions like that when it's a building structure. See, what I'm trying to say is you can have a thing like this. Yeah. And then a steel structure mounted on top of this. Now you have a base plate here, something like that here.
Yes.
This is something else. This is
Correct.
completely something else. Yeah. This is real
True.
pedestal that you see as definition and in textbooks. Now, when you are talking about your monolithic local thickening of your column, yeah, something like this. See, you are already designing your column. Your modeling is from here, yeah, and your column is like this. So in this section, if I see, your column is only this much in your model. You have modeled it and designed it, correct? So now whatever extra you have here as pedestal, don't need any design as such, because see, your footing, see, you have a force from here, it's going to bend about this, and that's going to exert a compression here on this pedestal. But
Yes.
this cross section is already designed to take a huge load. So whatever extra here you have as pedestal, just need a nominal steel like this, or not even
Agreed,
that.
sir. Agreed,
Yeah,
sir.
so
My
there is,
question was,
yeah, so you don't have to hunt for that definition in the case of a building structure. That's what I meant.
very right, sir. I agreed. But as far as this steel base plate column arrangement, like pedestal has only one criteria to be decided. That is the dimension and the height ratio.
Yeah.
And as far as design is concerned, same philosophy, same formula goes for column and pedestal. There is no difference.
Yeah, it's
Am
a
I right, sir?
compressive member. It's a compressive member, yeah.
Yes, the only difference is the nominal reinforcement, that is 0.8 for column and 0.1 IS 456 for pedestals.
Correct. Yeah, you have
So
to
this
design
is
it
the
for
only
whatever. Yes, you have to design it for whatever moments and shear force and the compression coming in that.
in the same way.
Yeah, when it comes to a column, then you have the slenderness, eccentricity, minimum eccentricity, and things like that. Yeah, so that's not applicable. The slenderness moments and all that are not applicable for this. Yeah, that is something which you already know.
I was just sharing. So basically, to summarize, the definition only makes a difference for the ratio. That's it,
Yeah.
sir.
Yeah.
Okay.
So these kind of pedestals you can design like what you are seeing in your textbooks. When you have your column, you need to analyze it. You need to understand its sway. Based on that, as I have explained in the course, you need to look at the fixity length. Yeah, your effective length, all that will change based on your Q value and all that. So that kind of things will not come for this pedestal.
Understood, sir. Thank you so much.
Yeah. Anything else? I think we are almost 9:40. Yes, I will have to close it. Maybe I will take one or two last questions if you have. Anybody? Okay, so that's it from me. Yeah, so if you have any more questions, you can feel free to post it in the group or WhatsApp. But when you WhatsApp, I'm not sure when I can see that. Yeah, but I will see it, but then better to post it in the community. Yeah, so that it will not miss the attention. Yeah, I get quite a lot of messages, so sometimes I may not be able to respond to you. And also our WhatsApp number is shared on a network and on multiple systems, so many people are looking at it. Yeah, marketing and all that. So that's all from me. Thank you for being today. I hope you also got benefited from the discussions. We will have these kind of discussions, and if you are keen on the course, you can grab that for the current pricing. So great speaking to you. Good night.